Hello everyone. Today we're going to explore the mechanism for alkyne transreduction. So basically you start with an alkyne and you want to have an alkene with the trans configuration. Usually the reduction occurs with the Lindlar catalyzer and you get a cis configuration because it's flat on the surface and cannot go on both sides of the alkene. So today we're going to figure out why the hydrogens are being placed in trans position. So the first step is we're gonna explain why we're using a neutral state metal in NH3 solvent. So we're gonna use the electron of those metals. That's basically what's going to happen. So we have our neutral sodium in NH3. We're just setting the conditions here. And its electron. Or you can write it as that's a solvated electron. All right. So for the mechanism, we're going to reduce this compound. Sorry. Now, first step. We present the electron transfer. Right? So it's a single electron transfer, not a pair. It's one electron. Now we're going to have intermediary state. So the molecule is going to separate those alkyne fragments so that they have the less hindrance possible. In other words, they're going to be put in a trans position. If you recall your how alkene works, the most stable form is always trans. So the molecule is naturally going to tend towards that form. So let's do just that. From here on, I'll write them as R, just for the state. So here, both groups are separated. Now the orbitals, one of them goes back, like this. And this one just has the single electron, right? And it has a global charge. So the next player in the equation is the solvent, right? So the electron here are going to snatch this hydrogen, and the hydrogen is going to leave its pair of electrons back to the nitrogen, and we're going to end up with this radical right here. Oh, I inverted it, whatever. It's the same, I just okay, but it's still a radical, and we're gonna lose NH2. So far so good. And basically the rest of the reaction is the same thing repeated. So you get your second equivalent of metal to give its electron here, like this. Then you get two electrons. And it's an anion, so I'm gonna put brackets. All right, and the solvent once again. Like this. Grab the hydrogen, put it in the center, and then electron pair goes back, and we get our product. Okay. Hydrogen here, and that's a trick I use in exams. When the mechanism is long, I just substitute R groups, and at the end what I do is I just show that it goes back to being in this case I didn't plan this out, but you can see hydrogens are trans. You got your ethyl group, propyl group, and yeah, so that's the alkyne trans reduction mechanism. Thanks for watching. If you have any questions, feel free to leave them in the comments.